Hello everyone. Today we are going to see one more interesting problem from Blind 75 series, which is threesome. This is the second problem from the two-pointer pattern. This is very important one and it's very difficult to understand. Make sure to have a notebook with you and you can solve workout with me. First we'll talk about the brute force one. We just talk for a few minutes brute force solution and then we just dive into the better solution and then we just reduce some more time complexity and space complexity and we'll see optimal solution for this at the end. Right now let's see what the problem asks you to do is. So basically what the problem asks you to do is they will just give you a list of number. It can be a positive number, it can be a negative number, it can be between any range from minus infinity to plus infinity. It can be in any range. Your task is to find the unique triplet in the sense a three combination of number which will make up a sum to 0. I just written an equation that a plus b plus c should give you value 0. You have to find the unique pairs of numbers. I mean unique three pairs of numbers. So in this example, if you take minus 1, 0 and 1, if you add them up, you will get answer is 0. So we just add it to the result. And again, if we see another triplet, which is minus 1, minus 1 plus 2, if you add them up, you will get 0. So there are only two possible unique triplet from this array we can just get. Just remember, you need to have unique possible set. So without wasting much time, let's talk about brute force, like how we can approach this problem initially. So what we can do is initially just sort the given input. Okay, just sort the given input and have three nested for loop. Like one will be starting here and one will be starting here, one will be starting here. Just loop through it and add three I, j, k element and check whether if the sum is going to be 0. If it's 0, then make this tuple as a key. I mean this three number as a key and store it in a set. Okay, reason because you need to have unique pairs, right? So make it as a tuple and put it in your set and just do the process continuously. It's a very simple brute force solution and I think we don't need to waste time on it. So just have three for loop starting I will be here and j will be I plus 1 and k will be j plus 1. So it will be there. So just keep on going. First j pointer will go till the end and again this will just move here. So j will be here and again j will start to move all these places. So it will just find all possible unique tuples. I mean unique triplets. And if you talk about time complexity, so it will be big of n log n. Let me write out the time complexity. So this is going to be a time complexity for the brute force one. And obviously this is not acceptable in lead code or any interview. If you write this, it's not acceptable because see the time complexity. N log n for sorting the array and n cube is for what to tell 3 for loop and finding the triplets. So this is not a valid solution. So now let's think. Okay, so now I'll just rewrite this equation in much easier form to understand. Okay, let me rewrite this equation. So I rewritten the entire solution for better understanding. Now let's talk about the better solution. Just think like how you can reduce this of n cube time complexity, because we are running three loops. One will be going from I till the end and j will be going from I plus 1 till the end and k will be going from j plus 1 till the end. So this time complexity is going to be n cube. So what is the best possible time complexity you can reduce from this? Just think how you can do it. So you can just eliminate this thing, isn't it? You can eliminate it. How you can eliminate it? Okay, let's rewrite it first of all, which will be like array of k will be a negative of array of I plus array of j. This is simple mathematical equation. I just bring this what to tell, I just take this and bring it to this side, I mean right hand side of the equation. Let's assume that our pointer is here, one pointer is here and one more pointer is here. Now we need to find the value of k, am I right? We need to find array of k. So what is the formula? Minus of I. Let's assume this is I, this is j. What is the value of I? -1. And what is the value of j? Again, -1. So if you just do a math, so what will you get? You will get +2. You need +2 to make a triplet which sum will make a 0. So we just derive this equation from the given question and we just modified according to our own need. Now we need a value 2. So how you can find this value 2, whether how you will find whether this 2 is in this particular area or not. Just think, if you got right answer, that's fine, well and good. But for people who don't know, now let me tell like how you can tell whether 2 present or not is using hashing. If you remember the first few videos based on arrays and hashing, if you watched it, you might have guessed it correctly. Like, use hashing technique. Simply hash it and you can just find whether 2 is present or not. It's very simple. Hashing is very powerful. It's used everywhere. So you have to use it wisely. Right now, we just neglected O of n cube solution to O of n square by just simply rearranging this equation in the format of like this. And right now we just loop only 2 times, and instead of looping third time, we use this equation and check whether the element is there or not. So we just bring our time complexity from O of n cube to the O of n square. That's very good improvement. Now if you don't understand, now let's do a quick dry run. So one more important thing I forgot to tell is you cannot hash it at the beginning itself. The reason because, let me take one more example. If you take if you take I pointer is here and j pointer is here. Now if you apply this thing in an equation, it will look like x is going to be, let's assume array of k is going to be x. X is going to be minus of 2 minus 4. Now if you solve this equation, you will end up in +2. Am I right? But do you find +2 in this set? No, right? How could you just hash the entire thing? I mean, if you hash the entire thing, it will tell that 2 is already present. But you cannot use this value twice. I hope you understand. Like, what I'm telling is, we cannot directly set the entire number. If you do that, this equation doesn't works here, because if you solve this equation, you will get value 2. If you set the entire thing, now if you check for 2 is present, it will tell 2 is present, but according to the question description, it is not a correct logic, because you can use only element once, so you cannot use twice. So you can ask me, Magesh, how can I solve this particular problem? Again, if you don't understand, we are going to do a dry run, so you will understand very easily. So what we can do is, instead of hashing the entire sequence, what we can do is we can just hash the particular values alone. Let's say, for example, our pointer is staying here and our pointer is here. We can just hash this particular value alone. I mean, the in between values from the pointer. Just hash it. Now this problem won't occur. This is a simple solution. And if I want to give more example, let's assume the pointer is here, pointer is here. So your task is to hash only this particular element. Then you can tell that 2 is present or not. And now if you implement the same logic, let's do this here. And if you see our set, we will have only one element in our set. Am I right? Because there is only one element between these two things. But our x is +2. If you search in this set, 2 is not there, which is right according to the description. Now we won't add this to a set. Am I right? It's a very simple solution, and you can ask me how can I implement it. Now let's see that also, and we'll do the solution and we'll write pseudocode for it, and you'll be amazed. You'll be amazed when we are going to the optimal one. I'm sure that you will be amazed. Now let's do a dry run for it. Now right now I pointer is going to be constant, right? I pointer is going to be constant. Now j started to move. As a first step, let's write the equation. Now x is going to be, x is equal to minus of -1 plus 0. Am I right? So what is the equation? +1. And we'll have our hash set Okay, we'll create a one more hash. This is for result, this is for result, this is for current hash set. Remember, this is for current hash set. We just seen that hash is empty and one is not present in our hash. So what we can do is we can just move this j to the next position, and before moving it, just put this element to the hash. Okay, I mean hash or hash set. Put the element to the hash set. Now do the equation. -1 plus 1, and if we solve this, x is going to be 0. Check 0 is present in our hash or not. Yes, 0 is present. Now you can tell that the triplet of -1 0 1 makes a sum of 0. So we got our first triplet, so we can directly add this to our hash map. -1 0 and 1. I hope you guys understand. And now what you have to do is you have to move this pointer. And if you remember, like whenever we just moving the pointer, we need to add the element to one set. So just add one to a set. Okay. Now the equation will become like -1 plus 2. So it will be a +1. Again, +1 will become -1. So x is going to be -1. And we will check -1 is there in our set or not. Nope, -1 is not there. So just move the pointer to the next position and add the 2 to the set, current set. Now do the equation again. +1. Now what we have to do is, okay, if you rewrite the solution, the equation, it will be like minus of minus, -2, and again it will, if you do multiply with minus, it will be +2. Now x is +2. Check whether 2 is present in our set or not. Yeah, 2 is present. If something is present, we can easily make a triplet. Now let me write the triplet. It will be -1, this position, -1, comma 2. If we add them up, you will get a 0. So we've just found our subset. I mean one more triplet. Just add it to the hash. -1, -1, 2. And again, just move the pointer and add -1 to the hash. Now if you solve this equation again, it will be x is going to be +5. +5 is on our hash set. No, so you cannot find any triplet with with -1, -4 and +5. You cannot make it. Just leave it. Now first iteration has been completed. So once the iteration is completed, what you have to do is you need to reset the hash set. But if you look at it, so in between, like from this point to this point, like what the element is there is presented in our hash set. If you observe carefully, the element between these two elements, I mean first and last pointer, all the element is being hashed. That's what we talked in our solution for one particular issue. We talked right few minutes back. The solution is this. This is how you can implement the implement hash set for every iteration. Now once iteration is done, just clean up this hash set. It will be empty again. Now I pointer will be at this position. Now I will be at this position and j will be at this position. Now again, let's write the equation. It will be like minus of 0 plus 1, and x is going to be -1. So -1 is in our hash set. No, so just move j pointer to the next position. And if you remember carefully, we need to add 1 to our hash set because we just moved one position. So add 1 to our hash set. Now let's perform the equation. -2. So -2, check if it's an hash set. No, -2 is not there. So just move it. Now add 2 to the set. Don't forget to add it. Now let's write the equation again. It will be -1 and +1. Oh, sorry guys. Actually, I forgot to mention that while adding in the result, you need to sort it out. I mean, you need to sort the triplet and add it to the result. The reason because, again, if you see this particular exam, I mean the right run which we following it, the I pointer is here and j is here, and if we solve the equation, we just get 1. And if we check our hash set, 1 is there. So which means we just found a triplet, but the triplet is already exist. The triplet is going to be -1 0 1. but the triplet is already exist in our result. According to the question description, we should not have the duplicated one. So to fix this issue, what we can do is we can just sort it out. I mean, the sort the triplet and add it to the result set. And before adding to the result, we can check whether this triplet is already exist in our set or not. Okay, just keep this in mind. Before adding to the result, make sure to sort it out and then add it, so that we can avoid this kind of edge cases. That's why I said this problem is very difficult. If you take pen and paper and work out with me, then only you can able to understand it. Now let's move to the last element. Make sure to add -1 to the result because we just moved. Now if you solve this equation, it will be like +4. So do we have +4 in a hash set? Nope, we don't have. So just end the equation. I mean, just end the iteration. Now I pointer will be here at this position. Now j will be here. I guess it's enough because we already explained 2 iterations completely. So for now, let's stop the try run from here. And I think we obviously got our answer, I guess. Now let's check my set. Yeah, there are only 2 possible sets, so we already got them. And I forgot to mention that once the iteration is done, you should clean the hash set. Don't forget to clean it before moving your I pointer to the next position. Now let's write the pseudocode for it. Now let's start our pseudocode. Let's declare our set, I mean result set, and let's start our 2 for loops. So one will be running from I to 0 and j will next loop will running from I plus 1 to 0. Now let's apply the equation, and before that, if you remember, we need to implement the current set. Current set is going to be, let's write the equation. X is going to be minus of nums of I plus nums of k. It's so beautiful, right? This equation, we just found an equation. We just made our solution from n cube to n square complexity. Now a simple if condition, if x in current set, we can, I mean, which means we found a triplet. So before that, what I said is make a triplet which will have nums of I, then nums of j, and then x. If you remember carefully, we need to sort this out. Just sort it, sort the element, and simply add it to the result. Result dot add element. It's very simple. If this condition fails, what we have to do is simply add x to the current set. Current set dot add x. Very simple, right? It's a very simple code. At last, you can directly return a list of result because our result is a set. We declare a set for having a unique collection of triplets. So you can directly convert to the list and you can return as a result. I think I'm just confusing with the variable names. We need to return the result in a format of list, but our variable is declared using set. So we need to convert it to the result and then return it. That's what I mean. And the for loop is running from I to n, and this is our current hash map or current set, whatever you can call it. And then this is our inner loop, which will go from I plus 1 till the n, and the equation which we created is here. And simple checking, if the x is in the current set, add it to the element, sort it out, and add it to the result. And if it's not there, simply add it to it. And what we did here, like if it's not there, simply add it to it, and if it's there, sort it out and put it in the result. Very simple code. And let's analyze the time complexity of it. Now if you see the time complexity, it's going to be of n square. N square is for this two for loop, 2 nested for loop. And you can ask me, what is this 3 log 3? This is for sorting the 3 element. So we generally tell n log n, but in our case, the triplet is always going to have 3 elements. So we can directly substitute the 3 log 3. And if you see the big O rules, we can directly ignore it. And approximately it will be big O of n square. And if you talk about space, big O of n and big O of plus n. You can ask me, what is this, Mahesh? This is nothing but the current hash. This current hash is O of n space, and the result, this is for result. Again, if you just do approximation, it's going to be O of n space. This is the better solution. I mean, it's better than the brute force one. Brute force one is going to be O of n cube, and this is going to be O of n square. Now, we are going to use the similar idea, and we are going to solve this problem much efficiently. Almost going to be O of n. You will be surprised, like you will understand the power of 2 pointers right now, because you just come from O of n cube to the O of n square. Now you will see O of n solution, and space is also going to be O of 1. You will see the beauty of 2 pointers technique right now. To explain this optimal solution, I have taken a very big example for you guys to understand very much better. And I will just talk about this 2 pointer technique first of all. As a first step, what we have to do is we need to sort this entire list. And if you see, this entire list is already sorted because I need to explain it. So I written in a sorted format. Okay. So as a first step, you need to sort the given input. So sorting will take n log n time complexity. So let me write the time complexity also step by step. Now, next step, what we can do is we can have 2 pointers. I mean, we can apply 2 pointer technique. Okay, let me throw this somewhere else. Okay, I'll just throw it here. Sorry for it. Let me throw this thing here. We'll have I pointer will be here. Okay. We'll iterate array only once. Keep in mind, we are working to improve the n square to the n time. So our I pointer will be here. Okay. I pointer is going to be constant. And now we will have our 2 pointer technique. We'll just approach it. Okay. So one pointer will be there, let's say P1, and one pointer will be there, P2. Now what we'll do is we'll just sum this entire thing. So let's sum it up. It will be like -4, -2, +4. What is this? If you add them up, it will be -2. From this, like, what you can able to understand. So our target is 0, right? That the question asks you to find triplet which sums 0. So your target is right now 0. So, but apparently, if you see, 2 is less than 0. Now, in a sorted array, how could you increase the value? Just think, in a sorted array, how could you increase the value? Right now, if you add this 3 element, our value is -2, which is less than 0. But you need to increase the value. So how could you increase it in a sorted array? That's the reason we just sorted it. Okay, if you think carefully, in a sorted array, if you move from right to the left direction, the number is keep on getting decreased, and if you sum up, your sum also will get decreased. But if you move from right to left, your value will just keep on get increasing, right? And your sum also will just keep on increasing. If you do a graph, it will look like this. Initially the value will be low, again it will just go higher, because the array is sorted from left to right. Obviously the higher element will be on the right side. That's the reason if you move from right to left, the value will just keep on getting increased. And if you need a smaller value, I mean, let's take it as a +2. Now what you will do, you need to decrease the value, right? Because you need to bring value to 0. How do you do it? So to decrease the value, we just move the right pointer. Okay. And if you want to increase the value, you just move the left pointer. It's very simple concept. Okay. Now let's move back to the dry run. Now we just move this pointer to the next position. And again, just make sure that you skip the duplicate. So we already seen 2. We don't need to see 2 again. So just skip the 2 and move to the -1. Now our pointer will be here. Now let's do the equation again. -4, -1, +4. Again, -1 came, which is obviously less than 0. So according to the rule, just move the pointer to the next position. Now let's rewrite the equation. 4 minus 0 plus 0. Now if you see, we reached our target, which is surprising, right? Now we found the triplet, which is -4, 0, 4, which will give the value 0. Now let's directly push it to the result. Here you don't need to sort it out every individual element because you already sorted the entire thing. Here you don't need to sort out this triplet. You can directly push in any order, minus 4, 0 and 4. Okay, that's a very good approach. Now we found one triplet. Now what you will do, you have to move the pointers, and you already visited 0, so you just skip the value, skip to the new, I mean you have to move to the new value because you already found a triplet, right? Again, if a pointer is going to stand here, again you will get the equation, same equation 0. Again the code will tell that you found a new triplet, but this triplet already exists in our hash map. I mean, sorry, I'm just keep on telling hash map. Our solution is already exist in our result. So to avoid this case, what we can do is, if you see an element already, just skip it out. You can ask me how to find the elements already seen. It's very simple. What you can do is just look up the previous element. If previous element is same as this, which means it's already seen it. So just skip it until you find a new element. So if you just skip the value, we will be pushed to the new position. Yeah, this will be right here. Minus 4 plus 1 plus 4 is going to be 1, which is greater than 0. Remember, if you value is greater than the target, you need to decrease it. So come backwards. Again, the same logic, 4 is already seen. Go to the new position. Now new position is going to be this place. Now again calculate it. Minus 4 plus 1 plus 3, which is 0. Again we found a new set of pairs which is making a sum of 0. So just add it to the result. Minus 4, 0, sorry, it's not 0, minus 4 plus 1 plus 3. We just found one more triplet. Very surprising, right? Now move this pointer, I mean move the both pointer. It should be both here. And again, if you do this math, it will be again 0. Plus 2 plus 2. Now the value is 0. Again we found a new pointer. Add it to the result. Minus 4 plus 2 plus 2. Its example is so good, right? You can get a lot more edge cases from here itself. The time when you cross P2 with P1, you have to stop it. You have to stop looping it. Okay, this is the base condition. If you cross both of them, just cancel the loop. We found all the equation, I mean all the triplet starting with 4. Now what we have to do is we have to move the pointer to next position, which is 2. We need to, right now we need to find all the triplets starting with -2. Okay, I think we already seen a lot more examples, so we can directly write these pseudocode for it. If you want, I can just quickly give a dry run. So right now I constant is there, and here we have j pointer, here we have k pointer, or we can call it as p1 p2. Sorry, p2 is always at the end. Now if we sum this up, it will be -2 plus 4. Surprisingly, again we just got 0. Now add them to the result. It will be -2 4. And if you remember carefully, once we get the pair, you need to move both the pointers, p1 p2. Again, if you move here, it tells that it already seen, so just move it here. And I guess I don't want to do a lot of try runs. Now if you do new calculation, -1 plus 3. Oh my goodness, again we just found one more triplet. Let's add it to the result. -2 -1 plus 3. I think it's enough. Now let's move to the pseudocode. Sorry guys, I'm just rushing up because we already explained a lot more iterations, even in brute force. I mean the better solution in this one also. We already found this many pairs. I think it's enough. Now let's focus on the pseudocode. So as a first step, what we did is we just sort the given input, right? So let's sort it out. So nums dot sort, and then we'll have a result array. This time we are using an array, not a set. And then we'll iterate from I is going to be 0 till the end. And as an initial base case, we need to check if I is greater than 0 and nums of I minus 1 is equal to nums of. The reason why we are checking this condition is to eliminate the duplicate. For example, let's say we have again -4. So do you really need to compute all the triplets starting with -4? Do you really need it? I guess no, because we already found all the triplets starting with -4. So we don't need to do that. So we can directly skip the pointer and move to the next position. That's what this condition does. We just continue it. And if 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 it's not same, we'll just come here. And if you remember, we have two pointers, which is p1, which will be I plus 1, and p2 is always n minus 1. If you remember, p2 is always at the end, right? Each and every iteration it will be at the end. Now we will start a loop. P1 is less than P2. Okay, well, P1 is less than P2, and we'll have current sum nums of I plus nums of. Now we have to check if current sum is equal to 0. If it's 0, we can directly add it to the result. So result dot append, and we can directly add nums of I, j, and nums of I, p1, p2. Simple, right? The solution is simple. And we also seen the case where if current sum is less than 0, else if current sum is less than 0. If current sum is less than 0, we need to move to the higher altitude. Am I right? You need to go to the higher altitude in order to get a better value. For that, you have to move left pointer. Left in the sense that right now we have p1 as a left. So p1 is going to be plus plus. And the else condition, obviously the else condition is going to be p2 minus minus. When this condition occurs is if current sum is greater than the 0. So if current sum is greater than 0, we need to go to the lower altitude. Okay, so we just move from higher altitude to lower altitude. That's what p minus minus. And next step, what do you have to do? And if you remember, we need to what to do? After this adding to the result, just move the pointers. So p1 plus plus and then p2 minus minus. And then what you have to do is you need to skip the duplicates. Am I right? For that, what we can do is we can have a separate function right over here, which will skip the duplicates. I mean, right after this if condition, we need to have this loop. Yeah, this is the while loop. Let me explain what is this. Just store the left pointer in the temporary variable and just check if temporary variable is equal to nums of p1. If it's equal, just move the pointer. So p1 plus plus. Just very simple. If the next value is also same as temp, so it's just move on. The same logic which we talked. We have to find the new value. Am I right? So until unless this condition fails, we'll just keep on moving the left pointer. We have to do similar thing for the right pointer, but instead of incrementing p1, we just need to decrement it. So let me write while loop for that also. Yeah, now while loop has written for that. So now temporary variable will be p2 pointer, and then we'll check if temp is equal to p2, and if it's equal, so just decrement p2 p2. Now at last we'll just close the loop and we can return the result. It's very simple solution. Now if we talk about the time complexity, so this is a time complexity, this is approximate time complexity for this optimal solution, which is of n. Now you can ask me why this doesn't count. Actually it's we cannot define that it will be at it will found at first place, second place, third place. So at the worst case, we have to see the entire element. So it's a very worst case. But if you see the best case, you can easily find. For example, in the dry run, we found easily triplet, right? Very easily we found. So did we iterate every single element and found it? No. So at a worst case, it will be like we have to check all the element to get one triplet. But at the best case, you can simply find. For example, we just kept a pointer here and one more pointer here and one more pointer here. So initially you just easily got it. I mean, that's the reason why time complexity is O of n in the best case. But in the worst case, it can go up to again O of n square. It's a very worst condition. But the best complexity is going to be O of n and space is O of 1. Technically, we are not using any extra space other than the result. So the space complexity is O of 1 and time complexity is going to be O of n. I hope you guys understand this problem, and I just put a lot of effort in this problem and explained it very well for you guys. And I think it's time to write the code, and we'll write it there. So first step is we need to sort the given input. Am I right? So sort, okay, nums dot sort, and the next step is to declare the result. Next step, what we have to do is we need to start the next step. What we have to do is we need to start the loop from I is going to be 0 and till the length of nums. And if you remember, we'll check the duplicate. If I is greater than 0 and nums of I minus 1 is equal to nums of I. If this condition pass, which means there is a duplicate. So just continue it. And now we'll have p1 pointer comma p2. So p1 is going to be I plus 1. Am I right? And p2 is going to be n minus 1. Length of nums minus 1. Now we'll start the again while loop. It will be like p1 is less than p2 and current sum. Current sum is going to be sum of all three elements. So nums of I plus nums of, okay, sorry guys, actually I'm not a comfortable position to type. That's why I'm just doing a lot of mistake. Nums of p1 and nums of p2. If current sum is equal to 0, we can directly append this to the result. Result dot append nums of I, nums of p1, nums of p2. If current sum is less than 0, which means we need to go to the higher altitude. So p1 is going to be increment by 1. Else we need to go to the lower altitude. Lower altitude in the sense when we need to decrease the value. And I'm just keep on forgetting to increment our pointers. Right after adding to the result, we need to increment the pointers. P1 is equal to 1, then P2 is going to be minus 1. Now the important case, skip all left side duplicates. For that, what we did is temp is going to be nums of p1 and while p1 is less than p2 and temp is equal to nums of p1. If this condition pass, we need to increment the pointers. That's it. Until unless we find a new position, we just keep on incrementing pointers. And there is one more base case, which is point p1 is less than p2. No matter what, p1 should not cross p2. That's what this base case tells. And again, we have to do similar thing for the right side character. I'm not going to write it. I just simply copy paste it. And instead of p1, I have p2, and here also same. Here also just decrement the pointer. p2 is going to be decremented. And at last we can return the result. Now if we just run this, oh, we just did some syntax errors. Okay, let me clean this up. We did some mistake here. What we did something wrong. So let's debug alive. Oh, I did some crazy mistake. This all things should come inside the if condition. I mean, once the result is passed, we need to do this step. I'm an idiot. Okay, guys. Sorry. In explanation also, I forgot to tell this. I'm sorry, guys. I'm really sorry. So right after you push things to the result, you need to skip all the duplicates from the left side, right side as well. If there is no duplicate, it's very simple. Now let's run this. I'm sorry again. Okay. Just keep in mind, like whenever you push things to the result, you need to skip all the duplicates value. Yeah, right now it passed the test case, but let's submit this and see. Oh, at last we just passed all the test cases. I hope you guys enjoyed this video and you learned a lot, I guess. Even I also learned so much things, and this took a lot of time to explain it for you guys. Right now the time is around 3. Actually, I started recording at 2. It took 1 hour to record this video.